Every local LLM is hallucinating right now, and it's not its fault. The problem isn't the model, it's the data. Language models train on a massive snapshot of the internet, but that snapshot freezes the moment training ends. After that date, the model is flying blind. Today, we are fixing that with WebFind, a local-first, SurrealDB backed search engine built specifically for AI agents. There is an invisible wall between your local LLM and real-time knowledge. You run Llama or Mistral locally. It's fast and private. But ask about a library released last month or a vulnerability discovered yesterday, and it either hallucinates or gives up. It has no access to the present moment. WebFind provides that live connection privately on your machine. To understand WebFind, let's review how classic search engines work. The pipeline has three core stages. First, the crawler, a program that systematically browses the web, follows links, discovers new pages, and downloads their content. Think of it as a digital librarian collecting documents across the internet. The second stage is the index. Once pages are collected, the index maps every word to the documents that contain it. Inverted indexes and BM25 scoring make lookup lightning fast. The third stage is ranking. The ranker sorts candidates by relevance using keyword density, link structure, and freshness. WebFind brings this exact pipeline to your local AI. Every major search engine, Google, Bing, DuckDuckGo, follows this pattern: crawl, index, rank. Local LLMs don't need the entire web, they need relevant, fresh context when their training data falls short. WebFind was built specifically to bridge that gap. Cloud search APIs exist, but they come with API keys, rate limits, and privacy leakage. Sending search queries to third parties defeats the purpose of running a local model. We need a search engine that runs locally, speaks JSON RPC, and stays completely private. WebFind features a SurrealDB first architecture. It combines auto-discovery with two crawl engines, a lightweight spider for quick sitemap discovery, and a Google-inspired bulk crawler for deep analysis. All nodes, link edges, and full text live natively in SurrealDB, eliminating local index files in production serve mode. Phase 1 is discovery. When no seed URL is given, WebFind's auto-discovery module extracts query keywords, generates domain candidates, and validates them via DNS checks. The bulk crawler then traverses link depths using SIM-hash near-dub detection to drop redundant pages and storing graph nodes directly in SurrealDB. Phase 2 is prioritization. WebFind scores every URL using score1 CD1 plus depth plus keyword relevance. URLs at or below min-depth 3D are force-fetched, ensuring the crawler reaches deep documentation pages beyond landing screens. Phase 3 is fetching. Top-scored URLs are fetched per domain. Rate limits and robots.txt rules are strictly enforced. Each session uses rotating proxies, randomized device headers, and TLS fingerprints, falling back to Headless Chromium for JavaScript-heavy pages. Identity rotation prevents bot detection. WebFind's proxy pool rotates IP endpoints, while the session manager randomizes user agents and HTTP PUTU fingerprints using JA3 and JA4 profiles. All audit metrics log directly to SurrealDB's fingerprint audit log table, making requests look like diverse human browsing. After fetching, the content extractor cleans HTML via readability, extracts metadata, and computes readability scores and rake keywords. Everything normalizes into 35 structured fields inside a unified structured content object. Indexing uses a clean eSearch engine RAID with two implementations: in-memory search engine for rapid local unit tests and Surreal search engine for production. Surreal search engine runs native BM25 full text and HNSW vector queries directly inside SurrealDB. Search executes across two parallel paths inside SurrealDB. Native full text index performs BM25 keyword matching, while FastEmbed generates dense vector embeddings for semantic similarity. Both keyword and semantic candidates merge into the multi-signal ranker. The crawl graph store records page nodes, link edges, and page rank scores in SurrealDB. As content is fetched, an asynchronous background worker generates embeddings and writes page content in the background without blocking the search response. The ranker combines 5 signals: BM25 relevance, freshness decay, reading quality, page rank authority, and vector cosine similarity. Fresh content outranks stale pages, ensuring trustworthy, up-to-date results. Your LLM communicates with WebFind via Model Context Protocol on streamable HTTP port 4748. WebFind exposes 4 tools: WebFind Search, WebFind Research, WebFind, fetch, and WebFind graph. Here is the key distinction. WebFind search queries known URLs already in SurrealDB and refetches them for fresh live content. WebFind research, discovers and crawls new URLs not yet in the graph, persists them and returns results. All MCP tools accept an ISO 8601 timestamp parameter. When passed, WebFind automatically injects the current year into queries. The WebFind graph tool lets your LLM traverse crawl link structures and PageRank scores directly. Deployment is simple. WebFind runs as a Docker container alongside SurrealDB on HTTP port 7790 and MCP port 4748. No external dependencies, no API keys, and zero data leakage beyond your machine. SurrealDB is the single source of truth for the entire architecture. It stores document nodes, full text search indexes, HNSW vectors, link graphs, audit logs, and background crawl jobs in a single unified multi-model engine. Putting it together, your LLM requests context via MCP, auto-discovery finds seed candidate URLs, the dual engine crawler fetches content, the background worker indexes into SurrealDB, and the 5-signal ranker returns precise results locally. That is WebFind, a local first, SurrealDB backed search engine built for AI agents. In part 2, we will set up Docker Compose, configure SurrealDB, and run a live demo. Subscribe so you don't miss it.